Welcome back, engineers. In our last video, we stepped into the real world, exploring how companies like Airbnb, Pinterest, and Slack use nested endpoints, access control, and query parameters to power their APIs. We even uncovered how Twitter uses rate limiting to handle massive scale with ease. Today, we go deeper. We're diving into query parameters, not just how they work, but how to use them in the right way: clean, scalable, and secure. We'll break down the best practices top engineers follow in production, from designing flexible filters to preventing overfetching and underfetching. And yes, we're also going to look at some of the most common tricky interview questions that can confuse even experienced developers. By the end of this video, you'll understand things clearly, see helpful examples, and be able to build better APIs and explain them with confidence. Let's get started. Alright, let's start with best practice number 1. Use query parameters for filtering resources. In RESTful APIs, query parameters are a powerful tool for building flexible, dynamic filtering, especially when the filters are optional and can change from one request to another. How do you dynamically filter records based on optional parameters? Here's the answer: use dynamic querying. Instead of hard coding conditions, you build your query object on the fly based on the parameters provided in the request. This lets your API support filters like slash messages, question mark, unread equals true, and sort equals desc without enforcing rigid structures, giving both flexibility and clean logic. How can you support advanced multi-criteria filters in APIs? The answer: multi-field filtering. Let's say your users want to filter tasks by type and priority, both optional. Here's how. By breaking down the query object like this, your API will only filter using the parameters that were actually sent, no extra checks or messy code. So remember, use query parameters to enable optional, powerful filtering while keeping your API logic clean, maintainable, and easy to extend. In interviews, don't just say, "I used filters in APIs." Show that you understand why you use dynamic querying and how it makes your API flexible and maintainable. The more clearly you explain your logic, like building filters conditionally or handling optional params, the more confidence you give that you've handled real world scenarios, not just followed tutorials. Now let's move on to best practice number 2. Limit the depth of nesting in your URLs. Deeply nested URL paths might look neat at first, but they can quickly get messy, too connected, and hard to manage as your system gets bigger. How do you structure URLs for deeply related resources without excessive nesting? The answer is resource linking. Instead of going deep like this, you link directly to the relevant resource using a cleaner path. This keeps your URLs focused on the resource being accessed, not the entire hierarchy above it. What's the best practice to avoid overly complex URLs in REST design? The answer is stick to a flat hierarchy. Here's a better design pattern. This endpoint still shows that issues belong to a project, but it avoids too many layers. It's clear, easy to understand, and works well for both front-end and back-end. The main point is, don't make your endpoints too deep. Use short, clean URLs that go straight to the resource, and add extra details using query parameters or in the response when needed. In interviews, it's not just about using REST, it's about using it right. Keeping your endpoints simple shows you understand how to keep things clear, organized, and loosely connected, which is important as your system grows. So when you explain your API design, highlight why a clean, flat structure makes your services more maintainable and scalable. That's what interviewers are really listening for. Next, let's check out another important best practice in query parameter handling. Next up, and this one's critical, best practice number 3. Always validate your query inputs. Query parameters might seem safe, but attackers often use them to target your APIs. If you don't check the input carefully, it can lead to injection attacks, slowdowns, or strange behavior. How can you ensure query parameters are safe from attacks? The answer: schema validation. A well-defined schema tells your API exactly what it expects and rejects anything that doesn't match. This stops users from sending harmful text, wrong data types, or fields that don't belong, keeping your backend safe from bad input. How do you prevent misuse or unintended behavior from query parameters? Use strict typing, even in JavaScript. For instance, by explicitly checking types and ranges, you ensure the request behaves predictably and your system doesn't crash or misfire due to unexpected input. So the rule is simple: never trust query input. Always validate, sanitize, and enforce the correct types before using those values in your logic or database calls. Query inputs may look simple, but skipping validation is a common pitfall. When you explain how you validate parameters with schemas or type checks, You show that you're not just focused on functionality, but also on security and reliability. Always back your answers with how you protect APIs from bad input. That's a sign of real world experience. Let's keep going. The next best practice makes sure your API stays flexible without becoming unpredictable. Now let's talk about best practice number 4, combine query parameters with pagination. When dealing with large data sets like thousands of items, users, or messages, you should never return everything in one go. It kills performance and overwhelms both the server and the client. That's where pagination comes in, and query parameters make it simple to implement. What's the best way to serve large datasets in chunks? One widely used method is offset pagination, using limit and offset values to fetch a specific window of data. This makes requests like /items, limit equals 10, and offset equals 20 easy to build and predictable to paginate. Perfect for admin panels, dashboards, or public feeds. How would you improve performance over offset pagination in large datasets? The answer is cursor pagination. Cursor-based pagination is faster and more scalable, especially for real-time or ever-changing datasets. Instead of skipping rows, it uses a stable reference point, like an ID or timestamp. This is how platforms like Twitter or Instagram paginate feeds, because it's efficient even as the dataset grows. So the takeaway: combine query parameters with pagination logic to create a smooth and performant API experience. And when scaling up, choose the right strategy: offset for simplicity, cursor for speed. In interviews, saying we use pagination isn't enough. What matters is whether you understand when to use offset versus cursor based pagination and how it impacts performance and scalability. So, walk through your pagination logic clearly. It shows you think about user experience and backend efficiency. Up next, let's look at how to handle defaults and optional behavior the smart way. Now for best practice number 5. And this one is all about security. Avoid sending sensitive information through query parameters. Why? Because URLs, including their query strings, often get logged in server access logs, browser history, analytics tools, and even shared by mistake. Why should authentication tokens not be sent via query strings? Because query strings are not secure. Anyone who can see the URL can grab the token and use it to impersonate the user. Instead, the correct approach is header-based authentication. This ensures the token stays in the request header, not in the browser address bar or log files. How do you securely pass API keys in production environments? Again, use authorization headers and not query strings. This method is commonly used in OAuth, JWT, and modern APIs. Secure apps like Stripe, GitHub, and Google use it because it keeps login details safe from logs, URLs, and front-end leaks. So the rule here is simple. Never send tokens, secrets, or credentials via query parameters. Stick to headers for sensitive data and keep your API secure by design. Security isn't just a backend concern. It's a core part of good API design. By keeping tokens and API keys out of query strings and inside headers, you protect your users, your data, and your system from unnecessary exposure. When you explain this in interviews, you're not just showing that you know how to build an API, you're showing that you know how to protect one. And speaking of interviews, up next, we'll go deeper into real world advanced interview questions that test how well you really know query parameters. From edge cases to performance bottlenecks, we're going to break down what top tier companies are actually looking for in API design conversations. All right, engineers, we've seen the best practices. Now it's time to test how deep your understanding really goes. In top level interviews, especially at companies like Airbnb, Twitter, and Meta, you'll often face advanced API design questions. These don't just test whether you've used query parameters, they test whether you've designed and defended your decisions at scale. Let's walk through 5 of the most common and critical advanced interview questions around query parameters with real code and real reasoning. What is the difference between path parameters and query parameters? This is one of the most common foundational questions that interviewers ask to assess your understanding of RESTful design principles. Answer: path parameters are a core part of the resource's identity. They are used when accessing a specific item. Query parameters, on the other hand, are used to refine or modify how that data is returned, typically for filtering, sorting, or pagination. Example: the key distinction: path equals what you want, query equals how you want it. Explaining this clearly shows you understand both URL design and API usability. Question number 2. When should you avoid nesting in REST URLs? This question checks if you can design APIs that are clear, flexible, and easy to manage, especially when dealing with complex data relationships. Answer: Avoid deep nesting when the child resource can stand alone, or the path becomes long and overly specific. Excessive nesting ties your API too closely to internal data structures, which makes it fragile and hard to evolve. Instead of this, use a flat query-based approach. This improves reusability and flexibility, making your endpoints much easier to consume across different front-end flows. Question number 3. How do Airbnb or Slack handle filter logic securely? This is a high-level question that evaluates your security mindset, especially when working with dynamic filtering APIs. Answer. Companies like Airbnb and Slack don't accept random query inputs. They make sure white-listed parameters, strict schema validation, rejection of unexpected fields. Example, this ensures your APIs only process expected inputs, preventing abuse, confusion, or performance degradation. Question number 4. How can you enforce consistent pagination across your API endpoints? This question checks whether you understand not just pagination, but how to make it reliable and scalable across a growing code base. Answer. Use a consistent convention like limit and offset across all endpoints and enforce sensible defaults and caps to avoid abuse. Example. This improves developer experience and protects your backend from excessive load, making your APIs production safe by design. Question number 5. How do you handle query parameter validation in large-scale systems like Twitter or Facebook? This question digs into your architecture level thinking, especially around validation, reusability, and security at scale. Answer. At scale, validation must be centralized. Teams use middleware and schema libraries like Joy or Zod to enforce input contracts before requests hit business logic. Example using Joy. This promotes consistency, safety, and reusability, allowing validation logic to scale along with your system. Up next, we're diving into something foundational for long-term API evolution, API versioning. We'll explore how modern platforms version their APIs, manage backward compatibility, and safely introduce breaking changes without disrupting users. See you in the next video where we break down API versioning strategies that power real-world systems.